Hi guys, okay, today we are going to be looking at changes of state, and that is in the particle model module of your GCSE. So can you grab your pencils and get yourself set? You need to copy along with me as I do this, thinking about what's going on and trying to remember the detail. Okay, let's start off with some basic ideas. Okay, you should have learned at Key Stage 3 that there are 3 states of matter. The first one being solid, and in a solid we have neat rows of particles that should be touching, but my poor drawing there is not allowing them to touch. Okay, so solids have a fixed shape. They have a fixed volume, and they have high density. Okay, and density you should remember from the last lesson. So I'm going to colour these guys in blue. Okay, and I'm going to continue to use the same colour for all of these because we are looking at one material only. Okay, and that's when we're talking about the density, the amount of energy and things that we're going to come on to in a bit. It's important to remember that we are just talking about one. We're not comparing different chemicals. We're looking at only one. So the next one, obviously, is a liquid, and a liquid has got a similar situation that the particles are pretty much touching. 1, 2, 3, 4, 5, and 6, but they're not in a regular arrangement like we'd call the solid. Okay, so the solid is in a regular arrangement, the liquid is not. So these basic things, these fit a container, fits the shape of a container. Okay, they have a fixed volume, and they have a high density. Okay, but I will add that it is slightly lower than its solid. Okay, so let's not get confused here. I'm talking about one material, so I can't compare. For example, you all know that if you took a piece of wood, which is a solid, and you chucked it in a river, a lot of the times if that wood's dried out, then it will float. Okay, so obviously that piece of wood has a lower density than the water. But we're talking about, in general terms, the density of the liquid most of the time, okay, is lower, slightly lower than its solid form. There is one glaring and famous exception, which is water, because if you stick an ice cube in a glass of water, you know that will float. But that is an exception, okay? So let's move on, and I'm going to zoom out a little bit here. We're now looking at a gas. Okay, and a gas, as you can see, I've had to zoom out a little bit, okay, which tells you something about the density. The density is a lot lower in a gas than in the solid and the liquid, but I've still drawn 6 particles, and I'll come back to that in a sec. So, what do we know about a gas? These are also able to move, so I'll put some little movement markers in there like that. Okay, so what do we know about a gas? Well, it will fill a container. Okay, because all those particles are whizzing about so quickly that they will be bouncing off not just the bottom and the sides, but also the top, so that will fill the container up. Okay, the volume can be changed. You can compress a gas. Okay, as I'm sure you're aware, you can squash it, squeeze it in. I'm just going to move my laptop out of the way a little bit. And it has a lower density than its solid and liquid forms. Okay. So in general, if you were to mix the solid, liquid and gas of a substance, you'd find that the solid is at the bottom with a layer of liquid on top and then the gas at the right at the top. So you should know that from your previous science career. Key Stage 3 teaches you these diagrams and teaches you these basic properties of all of those three states of matter. What we're going to look at now is how to change between from one state to another. So if I want to go from a solid to a liquid, obviously, okay, I need to apply some heat. Okay, what I'm doing when I apply heat is giving the particles energy. Okay, so I'm going to put energy plus plus. So as I give these particles energy, they start to move. When they've got enough energy, okay, they will overcome the forces of attraction that there are between these particles in a solid. Okay, you know that everything's held together by some kind of bond or force of attraction. Okay, and a bond is just a form of force, a form of attraction. Once they've got enough energy, they'll be able to move past each other. Okay, and then we've turned it into a liquid because a liquid can flow. Right, that's another point here. Okay, it is a fluid. Okay, can flow. Right, and it's important to remember that not only is liquid a fluid, and we say, oh, make sure you take enough, make sure you drink enough water, take in enough fluids, but actually, in terms of physics, a gas is also a fluid because a gas can flow as well, because the particles can move past each other. So that's what we're talking about. We're talking about fluids in physics. So we've given these particles here enough energy. They start to vibrate, they start to move, and eventually they'll have enough energy that they'll overcome the forces of attraction between the particles. They'll be able to move. There is still some attraction here though. Okay, so they don't just zoom off into the atmosphere or into the surroundings. They can move past each other. If I continue to apply energy here, heat again, my handwriting's going to go a bit funny here. Heat, oh yeah, actually that looks all right. I'll just do it lowercase. Heat, okay, and again, giving it energy. Okay, then eventually those forces of attraction will be overcome and these particles will whiz off into the atmosphere and turn into a gas. So what's key here is that these guys are increasing in energy, okay, until we get up to the gas phase. So there is also, and some of you may already know this, okay, there is also another way. You can see that we've gone around this corner here. Some substances can go directly from a solid, okay, to a gas at standard temperature and pressure on Earth, okay, and this is called sublimation. Now, I believe you should have encountered sublimation from whenever you did this topic in year 7, 8 or 9. Okay, so again, we are giving it energy, so I'll say energy plus plus. Okay, and there's two examples that I want to give you here. Okay, and they are iodine, I2, and CO2, okay, carbon dioxide. So you'll have seen, if you've seen a smoke machine, smoke machines use, not smoke machines, but some smoke machines use carbon dioxide and they just heat up blocks, or they just have solid carbon dioxide in them. It's left to warm up because it has a melting point of a boiling point of around 70 degrees, minus 70 degrees C, I believe, and that will then turn directly from a solid into a gas. Okay, and that's called sublimation. And again, I'll get the old purple pencil out here. That is increasing energy. Increasing energy. Okay. So what we need to know are the terms. Well, we've learnt sublimation. Okay, and we're again adding heat to that. When we turn from a solid to a liquid, we should all know that that is called melting. When we go from a liquid to a gas, we should know that that is called boiling, or vaporization. Okay, now how about coming back the other way? Well, what we then need to do is reduce the amount of energy, and we reduce the amount of energy by cooling it down. Okay, so we'll cool this one down, and we'll say energy minus minus. Okay, so we're taking energy away. As we're cooling this down, then it's losing, each particle is losing energy to surrounding particles. Okay, and eventually when they lose enough energy, they'll stop moving as quickly. They'll start to clump together. Okay, and when they clump together, we'll get those attractions will start to form again, because they don't have enough energy to overcome them, and you'll turn it back into a liquid. You'll see this is happening all the time in the atmosphere, okay, in clouds. So you've got water vapor forming, okay, and it forms little tiny droplets, which are the clouds, and eventually when those droplets get big enough, because they keep bumping into other droplets and getting bigger, once they're heavy enough, they will fall to earth as rain. Okay, so that is called, as I'm sure you're well aware, condensation. Condensation. Okay. If we continue to cool our liquid down, again, all the particles are going to be losing energy to the surrounding particles, to the environment around it. Okay, so we're cooling it again. Cool. And we'll say energy minus minus. And we're going to call that freezing or solidifying, sorry. Okay, solidifying. So again, these particles here, they still have some energy, okay, and they will lose that energy to the surroundings, and eventually they'll form into this regular, rigid arrangement again, okay, because they don't have enough energy even to move past each other. And we call that freezing or solidifying. It's important to remember that these guys have still got energy, okay, because they're still vibrating a little bit. You'll remember that again from your Key Stage 3 science lessons. They're still vibrating a bit, so they've still got some energy, but they just don't have as much energy as they had when they were liquid, and they certainly don't have as much energy as they had when they were a gas. So let's go from a gas down to a solid. Okay, and we'll call that cool energy minus minus. So once we've gone from a gas to a solid, it's similar again, it's just we're not going through this liquid phase here. We're losing energy to the particles until to the other particles around them, or to the environment, until they've lost enough energy that those bonds form again. And we will call that, well, the language that I've just had a quick look through your textbook is in there. We call that condensation in that textbook. But I've also seen that called sublimation. And I've also seen it called deposition. Okay, so make a note of all of those. They all mean the same thing. Okay, there we go. So that is that is the basics. That's basics of changes of state. We're going to look at more in depth into energy. So what you should have learned from this is we've recapped the 3 main states of matter. Okay, we've talked about their properties. We've talked about how to get from one to the other, okay, and back again. And it's all about increasing energy or decreasing energy. I suppose I should probably put that on there as well. So here, coming back that way, we are decreasing energy. Decreasing energy. Okay, and here we are also decreasing energy. I'll do it like that. Okay. Energy. Okay. What I now want you guys to do, and don't put this onto your own, don't put this on your diagrams, but I'm just writing it down here so you've got a record. I want you to look at your changes of state section of the Word document that is called 6.3 particle model. And I believe it is page 12 to 13, okay? And what I'd like you to do is read that section where it says change the state. It covers basically what I've just covered in this video. And then I want you to answer questions 1 to 13. Okay, questions 1 to 13. Okay, do it on a Word document that has got your name, and then hand it in to me. Okay? Right, good luck with that, guys. If you've got any questions, ping me an email or send me a message on Teams. All right? And don't forget to wash your hands, guys. All right, bye.